So if you're watching this video, you've probably gotten to a point in school where you're working on fractions and you've been adding and subtracting fractions probably, and your teacher has said to you, well, you added those right, but they're not in lowest terms, and all your fractions need to be in lowest or simplest terms. When I was in school, we used to say we reduced the fractions. So fractions need to be in lowest terms or simplest terms. We call that simplifying fractions. And it really just means that you want to write your fractions using the smallest possible numbers that you can. So if you think back, and many of you have probably been adding fractions and subtracting fractions already, and if you have, you probably remember that if you have a problem like this and you say 1/3 plus 2/6, well, we can't add thirds and sixths. You have to change the fractions. So if I take that and I say, well, I can change this 3 in the denominator, I can change it into a 6 by multiplying. So I can multiply it, the numerator and denominator both by the same number. Changes this into 2/6. 1 times 2 is 2, 3 times 2 is 6. 2/6 plus 2/6 is 4/6. It's pretty simple. That's the way we start with making equivalent fractions, because that 1/3 is really equal to the 2/6. It's the same thing. Same thing. This 2 halves that we're multiplying by right here, 2 halves, if you have 2 halves of something, you have the whole thing. Okay, so really that 2 halves is equal to a 1. So you're not changing anything. You're not changing any values. You're just making it look different. And that's what you're going to do when you are reducing or simplifying fractions also. You're just going to make it look different. And when you get an answer like this is the correct answer. 2/6 plus 2/6 is definitely 4/6. But that is not in the simplest terms. It is not in the lowest numbers we can write it in. So in order to take that fraction, 4/6, and write it in simplest terms, we have to think about what are we going to divide by. Over here we multiplied to make it bigger. But over here we want to get the fraction to the lowest numbers. So we don't want to multiply, that's going to make our numbers bigger. In this case we want to divide. Remember that multiplication and division are just, they're opposites of each other. You know, and if you think about fact families, okay, if you have 5 times 2 equals 10, you can take all those numbers, you can say 10 divided by 5 equals 2, right? It's the same thing. 2 times 5 is 10. I mean, you can move those numbers around everywhere. You can say 10 divided by 2 is 5. This is all part of the same fact family, using this 5 and 2 and 10. 10 is the answer to the product, and 5 and 2 is the factors. So this is an example. We're not going to use 5 and 2 up here, obviously, because we don't have 10. But we're going to find something. We're going to find a number that we can divide both 4 and 6 by. This one's pretty easy. 4 and 6 are both even numbers. That's one of the first strategies I teach students is if both numbers are even numbers, you can always divide it by 2. So you can take that number and you can divide it by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. I always look at the fraction again, because sometimes I didn't pick a big enough number and these numbers can still be made smaller. In this case, there's the 2 and the 3. There is not another number that I can divide into both 2 and 3 evenly. Okay, we don't want to use 1 because that wouldn't change it. We could say, well, I can divide them both by 1. You can do that and you end up with the same number. So that's not going to advance it any. That's not going to make it any different. So we're not going to divide by 1. So let's do a few more examples. All right, if I take a number, I'll take in this case I'll take 4/8. So this fraction, and last time we were talking about fractions, we said they're both even numbers. You can divide them by 2. So you can certainly do that. You can divide both of these numbers by 2. I know that because they're both even. 4 divided by 2 is 2, and 8 divided by 2 is 4. Remember what I said last time. You have to look at this fraction again. 2/4. Now they're still both even numbers. So I can divide them by 2 again. 2 divided by 2 is 1. 4 divided by 2 is 2. Well, whenever you get a 1, you know that's lowest terms. That's as far down as you can go. But we had to do 2 little division problems in this case. If you take that same fraction, and you're good at your multiplication tables, and you think about it, and you say to yourself, I wonder if there's a bigger number than 2 I can use. Well, I know that 4 and 8 are both multiples of 4. So I can use 4. I can say 4 divided by 4 and 8 divided by 4. And I get 4 divided by 4 is 1 and 8 divided by 4 is 2. I get the same answer in one step. Now it really doesn't matter if you use 1 step or 2 steps, as long as you keep going until you get to the smallest numbers that you can. The bigger number you start dividing with, the less dividing you have to do. Because if you think about this 4/4, we had 2 here and 2 here. 2 times 2 is 4. We just did it down here in 1 step instead of 2. Let's look at another example. If I have 10/15, okay, I'll look at it. Well, they're definitely not both even numbers. Another rule I teach students: look for zeros and fives. If it ends in a 0 and 5, you can divide it by 5. So let's try that. Divide both of these numbers by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. I'm going to look at this fraction again. Is there any number I can divide both 2 and 3 by? No. That's it. This is lowest terms. Okay, doing another example. Take the fraction 20/24. Again, I can look at that fraction and say to myself, well, they're even numbers. I can definitely use 2. 20 divided by 2 is 10. 24 divided by 2, I know 2 times 12 is 24. I'm looking at my answer, 10/12. They're still both even numbers. I better divide again. 10 divided by 2 is 5. And 12 divided by 2 is 6. 5 and 6, there's no numbers I can divide both of those numbers by. So this is my lowest terms fraction. Again, I had to use 2. I'd divide twice. I'd use 2 numbers to divide by. So there's a bigger number I can use that will both go into both 20 and 24. In this case, again, like we had in the first example, the bigger number is 4. I know that I can do 4 times 5. So 20 divided by 4 is 5. 24 divided by 4, 4 times 6 is 24. I get my same answer. Same thing, 2 steps up here, 1 step up down here, gets you the same answer. I'm going to show you one last trick, and then I'm going to tell you if you want to know more about divisibility rules. In other words, how do you figure out what number to use if you don't know what number to divide by. You can go check out my video on simplifying larger fractions, and I go over the divisibility rules in a lot of detail there. But I'm going to tell you one really quick. This is one of my favorite numbers to use, because when I look at 51, it doesn't seem like that's a multiple of anything. I mean, it's not even, so I can't use 2, 4, 6, or 8. It doesn't end in 5 or 0. I can't use 5 or 0. It's not a multiple of 7. And I happen to know, because I've worked with this number a lot, and I know I use it for examples in my divisibility rule, this is actually divisible by 3. And I'm going to tell you how I got there. This is a rule that I learned, and this one's easy enough for me to actually remember. The sevens rule, I have had people talk to me about the sevens rule before, and I'll be really honest with you, I can never remember it. It's really complicated. It's not something if I'm concerned if something's divisible by 7, I just try it. But for 3, if I take the digits, I know 9 is divisible by 3. I know 3 times 3 is 9. This 51 doesn't seem like it should be. So I'm going to take my little threes rule, and I'm going to add the digits in the number. 5 plus 1 is 6. Can I divide that answer by 3? 6 divided by 3, yes, I can, yeah, that'll work. So if I can do that, then I can divide the original number by 3. So I can take that 51, and I know it's divisible by 3 because it fits my rule. 3 goes into 5 one time. Bring down my number there. 3 into 21 7 times. So this number, 9 divided by 3, is 3. And 51 divided by 3, we did right down here, is 17. Doesn't seem like it should work, but it does, and that's one that I really use all the time. So if you want to know about the other divisibility rules, I've kind of talked a little bit about them here, but I go into more detail in simplifying larger numbers. Hopefully this will help you out.